Hi there and welcome to another video for the Edexcel Core 3 Maths A-Level syllabus. In this video we revise past paper questions on functions. The video will be on questions such as domain, range, composite and inverse of functions. It won't involve modulus at this stage. As always, take a look at the question, pause the video, attempt it and then work through my solution marking your work. Okay, let's start. Right, it tells us we have a function. You put x in and you get 2x out. X can be any number that you put in, any real number. So another way of writing this is that f of x is equal to 2x. It asks us for the inverse function. Well, all this function is doing is taking an x value and doubling it. So obviously the opposite or the inverse function is take a value and half it. Simple as that. Now, we should know that the domain of the inverse function is the same as the range of the original function. What does this function look like here? Well, the original f of x function is the graph 2x, f of x equals 2x. We know that that takes any y value, all y values, and therefore its range is f of x is any real number. So that's the range of the original, and the range of the original is equal to the domain of the inverse. So therefore the domain for this must be x is a member of the reals. Okay, it then tells us about a function g defined as follows. This tells us we take an x value, we square it, then we triple it, and then we add 2. Another way of writing this is that g of x is equal to 3x squared plus 2, and x, the number we put in, the domain, can be any real number. Find g of f to the minus 1 of x. So we want to work out g of f to the minus 1 of x. We want to put in f to the minus 1 into g. Well, f to the minus 1 is x over 2, so this is equivalent to working out g of x over 2. So it's like putting x over 2 in place of x, so this would be 3x over 2 squared plus 2. And multiplying this out, we would get 3x squared over 4 plus 2. And that is our g, f to the minus 1 of x. And we're done for 2 easy marks. Next part, state the range of this function. Well, let's just copy the function over onto this page. Here was our function. So here's our function here. What's the range of that function? Always tends to be easiest to find the range of a function, draw what it looks like. So it's an x squared, it's a quadratic. Now an x squared normally looks something like this. A 3/4 x squared would be slightly shallower than this, maybe something like this here. And 3/4 x squared plus 2 means you shift up by 2. So you shift it up by 1 unit, 2 units. So that this point here, that line there is the line y is equal to 2, and that coordinate there is the coordinate x is 0, y is 2. So the range of this function are the y values it can take. What y values can this function take? Well, it can take any number bigger than or equal to 2. The way to write that is you can write y is bigger than or equal to 2. Probably a neater way of writing it is stating your function, the output of your function, g of f to the minus 1 of x has to always be bigger than or equal to 2. And you're done. And that's all your 5 marks. Next question, pause, have a go. Okay, it's asked us to find the exact solutions of this equation. This means, remember, log base e of 3x subtract 7 is equal to 5. What we can do to solve this, to remove the log base e, or ln if you will, take exponentials of both sides. So we would get 3x subtract 7 is e to the power of 5. Then we would add 7 to both sides, so 3x is e to the power of 5 plus 7. And then we would divide both sides by 3, x would be e to the power of 5 plus 7 divided by 3. And there you go, that is the exact solution. Do not type it in your calculator. It asks for exact values, not rounded values. Part B, we're trying to solve something like this. Now, a common mistake here might be to try and add the powers, because you've got 3 to the x multiplied by e to the 7x plus 2. You might try and add the powers and maybe combine this into 3e, I don't know, something like 8x plus 2. It's a total mistake. You cannot do that. The reason you can't do that is when you add powers, the base number has to be the same. The base here is 3, the base here is e. There are no exponential as such rules that work. What we can do is we can take a natural logarithms of both sides. Why I'm thinking to do that is that then maybe we can bring down the powers of x and get an equation with x that I might be able to solve. So let's have a go. Take natural logarithms of both sides. 3 to the x, e to the 7x plus 2. That dot just means they're timesing so I don't get confused, and is equal to ln 15. Now you should know that ln of a times b is ln a add ln b. There's a law of logs, so we can break this up into ln of 3 to the power of x plus ln of e to the 7x plus 2 is equal to ln 15. You should also know that something like ln a to the power of b is b ln a. I can bring down the power. So in this case, let's bring down the x and the 7x plus 2. We would get x ln 3 plus 7x plus 2 ln e is equal to ln 15. We should also know that ln e is 1. So therefore we have x ln 3 plus 7x plus 2 is equal to ln 15. Now I can subtract 2 off both sides to remove this 2 on the left hand side. So I would get x ln 3 plus 7x is ln 15 subtract 2. I can factorise the x here, so I can factorise out an x. X is a common factor in both x ln 3 and 7x. So I get x brackets ln 3 plus 7 is equal to ln 15 subtract 2. And lastly, I can divide both sides by the ln 3 plus 7, which is just a number, and I get x is ln 15 subtract 2 divided by ln 3 plus 7. And that's it. We have found the exact solution to that problem. It asks us to leave it exact, so don't type it in your calculator. 5 marks there. Okay, next, we're given two new functions, f of x and g of x, and we're asked to work out the inverse of f and state its domain. Well, f of x is e to the 2x plus 3, and the numbers you can put in are any real numbers. Now, I always find it handy just to draw these out, just to get a feel for what I'm doing. E to the 2x plus 3, I'm just going to draw bit by bit. E to the x looks something like that. E to the x looks like that as well, but it's slightly shallower here and slightly steeper here. So I'm just going to rub that out for now. I'm going to draw e to the 2x in a different colour, something like this. Still going through 0, 1. Now, e to the 2x plus 3 is like e to the 2x, but it's shifted up by 3 units. So therefore, it would be shifted up 1, 2, 3, and this point therefore would be 0, 4. This point at which it's asymptoting to here would be y is equal to 3, because it was previously asymptoting to y is 0, now it would asymptote to y is 3. Anyway, that's not part of this question just yet. They've simply asked for the inverse. You let y be your function, and you rearrange to make x the subject of the formula. Subtract 3 off both sides. Take logs of both sides, or natural logs. Bring down the power of 2x. And use the fact that ln e is 1, so we would just get 2x there. and then divide both sides by 2. X is therefore a half ln y subtract 3. Therefore, you should write down the page. I'm just going to go across here. You should therefore state that f to the minus 1 of x is a half ln of x subtract 3. Now, what's its domain? What x values can you put in? Well, the domain of the inverse is the same as the range of the original. The range of this original is y bigger than 3, so therefore the domain must be x bigger than 3. Also, you could have got that because you know if you put 3 in here, you'd be working out ln of 0, and ln of 0 is undefined. And we're done. Okay, next, pause, have a next thing, find fg and its range. So fg means put g of x into f. Now f was e to the 2x plus 3, so I better write these down. F of x was e to the 2x plus 3, and g of x was ln x minus 1. G of x was ln of x subtract 1. Okay, so to work out f of g of x, what we're really working out of is f of ln x subtract 1, because that is g of x. So that's putting ln x minus 1 in place of x. So that's the same as e to the 2 ln x subtract 1 plus 3. Now at this point here, you should know that a ln b, for example, is the same as ln b to the power of a. I can bring this number up as an exponent, so I could write this as e to the ln x minus 1 squared plus 3. And you should also know that e to the ln a is just a, so e to the ln x minus 1 squared is just x minus 1 squared plus 3. And this is our function f of g of x. There it is. What's its range? What values can it take? Well, luckily, we're in completed the square form. This is like an x squared graph, but it's been shifted to the right by a unit of 1, and it's been shifted up 1, 2, 3. So this coordinate here is not 0, 0 anymore, it's actually 1, 3. So what y values can it take? It can take y bigger than or equal to 3. Or the way to write that down formally is to say f of g of x is bigger than or equal to 3. And then we're done. A small point worth mentioning, is quite important actually, is that when you put x's 1 in, you get 3 out. The problem is with the original function, you can't put 1 in because otherwise g would be undefined. X has to be bigger than 1. Okay, so x has to be bigger than 1. So really, all we care about is this side of the line and not including when x is 1. So really, f of g of x, and this is correct, has to be bigger than 3. It can't actually be equal 3. And we actually don't care about this side of the line either, because x has to be bigger than 1 for g to even exist. Okay, next question, pause, have a go. Right, going through this, here's our function, show f of x is equal to this. Well, we've got f of x is equal to 2x subtract 1 over x squared subtract 2x subtract 3 subtract 1 over x subtract 3. And we're told x has to be bigger than 3. Always with these, before you launch into them, factorise. The top can't be factorised anymore. The bottom neatly factorises to x subtract 3 x plus 1 over 1 minus x subtract 3. If adding fractions, if you want to add or subtract fractions, denominators have to be the same. You've got x minus 3 here and an x minus 3. However, you've got a factor of x plus 1 here. So this second fraction must be multiplied on top and bottom by x plus 1. And therefore you would get on the top, then you could do the subtraction, you would get 2x subtract 1, subtract x plus 1, all divided by x subtract 3, x plus 1. Actually, at this point, I'm just going to highlight this here. Actually make that a bit smaller. And I'm going to start working down this side of the page here. You should work down the page in an exam. Here, expanding the top, you would get 2x subtract 2. Here you would get subtract x subtract 1, all divided by x subtract 3, x plus 1. Okay, and moving over here, this would give you x subtract 3 over x subtract 3, x plus 1. And look, as we imagined, there is a cancellation here, and therefore you get 1 over x plus 1, and you're done. You got what's required for the 4 marks. Next part, find the range of f. The range of f. Now f was this function here. It's easier to find the range of this here. So f is now an easier way of writing it is 1 over x plus 1. We are told though that x has to be bigger than 3. We're told x has to be bigger than 3. So what does this graph look like? To find the range of anything, draw its graph. 1 over x plus 1, well that's like 1 over x, which looks something like this here. But it's been shifted left by 1, like that. So it actually asymptotes at -1 here. Now, a key thing here though is x has to be bigger than 3. So actually, in this case, don't care about here, and I actually don't care about here either. I only care about when x is bigger than 3. So if x is, so actually what the graph actually ends up looking like, if that's our x and our y axis, we only care about when x is 3, so it just looks something bigger than 3. It looks something like this, with that point there is 3. And it would go on towards infinity like that. Okay, so what's the range? Well, at 3, when x is equal to 3, f of 3 would be 1/4. So therefore, f of x is always less than 1/4. F of x is always less than 1/4. And that is our range in this particular case. But obviously x can't be negative as well, just to make that point. That will never go negative. So the way of writing it is f of x is between 0 and 1/4. Next, find the inverse of f and state the domain of the inverse function. Remember, f of x is given by an easier way of dealing with it is 1 over x plus 1. We're asked to find the inverse function. So you let y be f of x. You rearrange to make x the subject of the formula. So you multiply both sides by x plus 1. Expand out the brackets. And then make x the subject of the formula. So we get yx is 1 minus y. And therefore x is 1 subtract y over y. So therefore we could state that f to the minus 1 of x must be 1 subtract x over x. And that is the inverse function. Now what is the domain? Well, we knew from the previous part the range of the original function was between 0 and 1/4. And the range of the original function is the domain of the inverse. So therefore x has to be between 1/4 and 0 using that fact. Part D, we've got a new function and we're asked to solve f of g of x is 1/8. So g of x, our new function, is the function 2x squared subtract 3, and x can be any real number that you put in. f of g of x, well, that's asking us to work out f of 2x squared subtract 3. And f of x is 1 over x plus 1. So I'm just going to write here for our help, f of x is 1 over x plus 1. So what we're doing is substituting 2x squared subtract 3 in place of x. So we get 1 over 2x squared subtract 3 plus 1, which is 1 over 2x squared subtract 2, which is 1 over 2x squared subtract 1. And that's our f of g of x. Now, I'm just going to put this over here. I'm going to work across the page. You should always work down the page in an exam, but just for this, for these times, I'm going to work across so it fits on a page. We're asked to solve f of g of x is an eighth. So what we're asked to solve is 1 over 2x squared minus 1 is an eighth. Okay, so we can flip both fractions and state that 2x squared minus 1 must therefore equal 8. We can divide both sides by 2. We could add 1 to both sides. And then we could take square root so that x is going to be equal to the positive square root of 5, or x is going to be the negative square root of 5. And just double checking, x can be any number, so both of these are valid. Next question, pause the video, have a go, very similar. Okay, working through bit by bit, here's our function, and we're asked to show that f of x actually simplifies to this. Remember, x has to be bigger than 1. So f of x is 5x plus 1 over x squared plus x subtract 2 subtract 3 over x plus 2. When dealing with these, factorise everything you can see. The top of the first fraction doesn't seem to factorise. The bottom should factorise to x plus 2, x subtract 1, subtract 3 over x plus 2. Now, we've got a factor of x plus 2 in both. We need to have the same denominators if we're to add the fractions. So top and bottom of this must be multiplied by the other factor, x subtract 1. And then we can work out the top. It would be 5x plus 1 subtract 3 x subtract 1, all divided by x plus 2 x subtract 1. And we could try and work out the top. It would be 5x plus 1. Here would be negative 3x, and it would be plus 3, all divided by x plus 2 x subtract 1. Now I'm going to work across the page. You should always work down the page in an exam, just so it all fits in. Tidying this up, f of x is therefore equal to 5x, subtract the 3x is 2x, and 1 plus the 3 is 4, over x plus 2, x subtract 1. Factorise a 2 out of the top. And oh look, as if by magic, x plus 2's cancel, and you get yourself 2 over x subtract 1. And that's your f of x. And x must be bigger than 1 for it to be valid. And you're done. Your 4 marks are in the bag. Part B, find the inverse. Well, you've just worked out that f of x, a neater way of writing it, is 2 over x subtract 1, and the domain x is bigger than 1. The inverse function, you let y equal 2 over x subtract 1, and you make x the subject, so multiply both sides by the x minus 1. You would get y x subtract 1 is 2. Expand the brackets, yx subtract y is 2. Make x the subject of the formula, so keep the yx here, must be 2 plus y, and then divide both sides by y, x is 2 plus y over y. Then you can state that therefore the inverse function is 2 plus x over x. Part C, you've got a new function g of x, it puts a number x in, squares it and add 5. So g of x is x squared plus 5. It wants you to solve f of g of x is a quarter. So it wants you to work out f of g of x, make that equal to a quarter. Well, f of g of x is f of x squared plus 5. You're trying to solve that as equal to a quarter. And we know from the previous part that f of x is actually 2 over x minus 1. So f of x is 2 over x subtract 1. So I'll write that up here. So therefore, this here is 1 over, substituting x squared plus 5 in for x squared plus 5 subtract 1 is a quarter. That's what we're solving, which is 1 over x squared plus 4 equals a quarter. I'm going to draw a line down the page and continue my working down this side. You should keep going down the page. Therefore, you can state that x squared plus 4 must be 4. Flipping both fractions. Oh, just one thing I forgot here. F of x is 2 over x squared minus 1. So there should be a 2 there and a 2 there. My apologies. So therefore, when I flip both fractions, I still have the 2 on the bottom. Times both sides by 2. Subtract 4 off both sides. Square root both sides. X is therefore 2, or x is equal to negative 2. And we're done. Next question, pause, have a go. Okay, here's our function. Express that as a single fraction. 2 plus 3 over x plus 2. Well, this is like 2 over 1 plus 3 over x plus 2. To add fractions, the denominators have to be the same. Multiply the first one on top and bottom by x plus 2. Then you could add the fractions, so this would be 2x plus 2 plus 3, all divided by x plus 2. Now expand out the top and collect it. That would be 2x plus 4 plus 3 all over x plus 2, which would be 2x plus 7 over x plus 2, and you're done. The one thing x can't be still, x can't be negative 2. Okay, part B asks us to find an expression for the inverse of f. Well, we've just worked out that f of x is equal to 2x plus 7 over x plus 2. So we want to find the inverse. Let y equal 2x plus 7 over x plus 2 and make x the subject of the formula. Times both sides by x plus 2. Expand out this side so x is freed from within the brackets. Collect all x's to one side, all y's to the other. So I'm going to subtract 2x off both sides, and I'm going to subtract 2y off both sides. So I get yx subtract 2x is equal to 7 subtract 2y. Then I'm going to factorise the x. X is common in both of these, so factorise the x. And then I'm going to divide both sides by y subtract 2. And then I have x as the subject of the formula, at which point you should work down the page, not across, but to save space. You can state that therefore that f to the minus 1 of x is 7 subtract 2x, all divided by x subtract 2. And you're done. Part C, write down the domain of this function. Well, here's our function. And we should know that domain of f to the minus 1 is equal to range of the original function. Going back and looking at the original function, it's actually not so straightforward looking at the original function to state what its range actually is. But what you can do, so this is actually not relevant in this case, what you can do is, what numbers of x would make that problematic? Well, the only thing that x can't be is 2, because otherwise you'd be dividing by 0. So the domain is x is a member of the reals, but x also cannot equal 2. So this usually helps us here, but in this case, it wasn't so easy to spot what the range of f was, so we went back to looking at the function and deciding what x values are problematic. Next question, pause, have a go. Okay, we've got two functions, f and g, find the inverse. F of x is defined as 1 subtract 2x cubed, and we're told that we can put any real number in there. So to find the inverse, let y equal to 1 subtract 2x cubed, and rearrange so x is the subject of the formula. So I'm going to add 2x cubed to both sides and subtract y. So I'm going to say 2x cubed is therefore 1 subtract y. Halve both sides, x cubed is therefore 1 subtract y divided by 2. And cube root both sides, x is therefore the cube root of 1 minus y over 2. And again, you should go down the page, not across, but therefore I can state that the inverse f to the minus 1 of x is therefore the cube root of 1 subtract x all divided by 2, and I'm done. Part B, show that the composite function g of f is that. Well, let's write down our f of x again. Our f of x is 1 subtract 2x cubed. Our g of x is 3 over x subtract 4. So our g of x is 3 over x subtract 4. So if we're working out g of f of x, what we're doing is putting f of x into g. So really we're working out g of 1 minus 2x cubed. So it's a case of substituting this in for x in this equation. So we would say 3 over 1 subtract 2x cubed subtract 4. Now, they want us to tidy this up. This here is really a fraction but over 1. If we want to subtract fractions, the denominators have to be the same. So multiply top and bottom by 1 subtract 2x cubed. And therefore we'd be able to tidy this up. It would be 3 subtract 4, 1 minus 2x cubed, all divided by 1 minus 2x cubed. And if we expanded this, it would be 3 subtract 4 plus 8x cubed, all divided by 1 minus 2x cubed. And therefore, just tidying this up, this would give us what the question asks for, 8x cubed subtract 1 over 1 subtract 2x cubed. And we've got ourselves our 4 marks. Okay, next part, part C, solve g of f of x equals 0. Well, we've worked out g of f of x. It's the following. So what we want to solve is this function that we worked out in the previous part equal to 0. Multiply both sides by 1 subtract 2x cubed. So we get 8x cubed subtract 1 is 0, because 0 times anything is 0. Add 1 to both sides. Divide both sides by 8. And take the cube roots of both sides. And the cube root of 8 is nice and neatly, it is actually a half, and therefore we're done. Okay, and the last part, use calculus, i.e. differentiation, to find the coordinates of the stationary point of the graph y is g of f of x. So our function is y is equal to g of f of x, which is this function here. So there's our original function, and we want to find dy by dx, so it's 5 marks here. Now, you should notice that there's a function of x on top and a function of x on the bottom. It is a u over v scenario. It is the quotient rule. So you let your u be 8x cubed subtract 1 and your v be 1 subtract 2x cubed. You differentiate u and you get 24x squared. You differentiate v and you get negative 8x squared. Sorry, negative 6x squared even. And then by the quotient rule, you know dy by dx is vu dash subtract uv dash all divided by v squared. So let's apply that formula here, dy by dx. I'm just going to move this over to one side here. So dy by dx is equal to vu dash, so this multiplied by this, so 24x squared 1 minus 2x cubed. Subtract uv dash, that times that, so it would be negative 6x squared 8x cubed subtract 1, all divided by v squared, which is 1 subtract 2x cubed all squared. Tidying up a little bit, what we could do is we could just say that that's 24x squared 1 subtract 2x cubed plus 6x squared 8x cubed subtract 1 all divided by 1 subtract 2x cubed squared. So that's our dy by dx. No need to tidy up any more than that. But what we have been asked for are to find the stationary points. So I'm going to extend the page. That's when dy by dx is 0. That's when this thing is equal to 0. Now we can multiply both sides by this denominator and it disappears. So we get 0 is 24x squared 1 minus 2x cubed plus 6x squared 8x cubed subtract 1. And I actually think the easiest thing to do here is to divide everything or factorise out 6x squared. If I factorise 6x squared, from this I'm left with 4 and this bracket. From this I'm just left with this bracket. So 0 must be 6x squared. If I multiply this out, I get 4 subtract 8x cubed plus 8x cubed subtract 1. So actually the 8x cubes cancel and I just get 4 subtract 1, which is 3. And I just get 0 is equal to 18x squared actually. It simplifies to something very similar. So therefore, the solution for this, you should have gone down the page, but I've run out of space. This, therefore, the solution is x is 0. And it asks for the coordinates. When x is 0, back in your original function, put 0 in here, and you would get y is equal to negative 1. Therefore, 0, negative 1 is the stationary point. Next question, pause the video, have a go. Okay, working through this, it says the function is an even function and it has domain for x bigger than 0, the following looks like that for x bigger than 0, and its whole domain is the real numbers, where a is positive. In the space below, sketch the curve y is f of x, showing all coordinates where it meets the axis. Well, imagine you let y be equal to x squared subtract 4ax. And you could factorise that as x subtract 4a. If you let x be 0, then y would certainly be 0 as one solution. And going backwards, if you let y be 0, what would the solutions be? Well, you'd get x is 0 if that was 0, or x would be equal to 4a, where a is a positive number. Okay, so what does this graph look like then? Let's have a go at drawing this graph. This graph has a root at 0, 0. It also has a root at 4a, which I'm going to put somewhere over here. And you know it's a u-shaped x squared, so it's going to look something like this. Now we're told the graph is an even function. That means that for x negative it also looks like that. So it would look exactly the same, where this point here is negative 4a and 0. So have we done what's required? Have we showed all coordinates where the curve meets the axis? Well, yes, there, there and there. And the even bit was a key point for us to be able to draw the graph. Okay, it says find in terms of a the value of f of 2a and the value of f of negative 2a. Well, f of x, let's remind ourselves, f of x is equal to x squared subtract 4ax. So f of 2a, simply substituting in the 2a, would be 2a squared subtract 4a multiplied by 2a, and it would be 4a squared subtract 8a squared, and it would be negative 4a squared. Now what's f of negative 2a? Well, you don't have to substitute in. You know it's an even function, so you know it must have the same value as f of 2a. So it's negative 4a squared as well. And you can state because it's even. And it then tells you that a is actually 3. And it says use algebra to find the values for which f of x is equal to 45. So f of x was x squared subtract 4ax. And f of x with a is 3 is therefore x squared subtract 12x. So let's draw our graph. Our graph did look something like this. I'm going to just copy that. That was our graph, which I'm going to make small. Where is that graph equal to 45? That graph is equal to 45 at this point, let's say, and this point here. So how are we going to find the values of x for which that's true? Well, all we have to do really is find the value of x for which that's true, and we know it's going to be the negative of that there. It's going to be the same value of x, but just a negative version. So what we can solve x squared subtract 12x, this branch, is equal to 45. Subtract 45 off both sides. Factorize, so you would get x, subtract 15, x plus 3 is 0. So you would get x is 15 or x is negative 3. Now you're going to ignore this one. This one here would be the case if the graph wasn't an even function, if it just was a continuation like that. It's not that. We're told it's an even function. So you're going to ignore this one here and you're going to just take this one. But you know there are two solutions, this one here at x is 15, but also this one at negative 15. So state the two solutions, x is 15 or x is equal to negative 15, and they are our two answers. Next question, pause the video, have a go. Okay, here's our function f of x and g of x. Find the range of f. F of x is given by x squared subtract 2x plus 3. We're told that x is any real number, but as long as x is between 0 and 4. Now, what does this graph look like in general? Well, if it can be factorised to x subtract, actually can't be factorised. Just looking at it, it doesn't actually work a factorisation, so there's no point going there. What does that graph look like? Well, what you can do is you can say if x is 0, what is y? Y would be 3. And you could also say what would happen if y was 0. If I tried to solve x squared subtract 2x plus 3 is equal to 0, Because the discriminant b squared minus 4ac is less than 0, there are no roots. So it doesn't actually cross the x-axis. So let's have a go at drawing it. We know that it crosses here at 0, 3. It doesn't have any roots, and it must therefore just go up like that afterwards because it's a U-shaped. Okay, at 4, if we put 4 into this function, 4 squared is 16, subtract 2 times 4 is 8, so it'd be 8 plus 3 is 11. So I do know that this point here, for example, is the point 4, 11. It even asks us to work out the range of this function. So to work out the range, if y was equal to x squared subtract 2x plus 3, I could complete the square. Y is x subtract 1 squared, and then you subtract 1 plus 3, you square this, you take it away, and you add on the end number. So y is x subtract 1 squared plus 2. So this point here is actually the point positive 1, 2. So 1, 2. So therefore, clearly the range is bigger than or equal to 2. So f of x is bigger than or equal to 2. But also, it must be less than 11, so f of x also is less than or equal to 11. So probably a neater way of saying it is that f of x is less than or equal to 11, but bigger than or equal to 2, and you're done. We're told that g of f of 2 is 16, and to find lambda. So g of f of x is the same thing as working out g of, and f of x is x squared subtract 2x plus 3. X squared subtract 2x plus 3. Now we know that g of x is given by lambda x plus 1. So therefore this is like putting this in for x. It would be lambda x squared minus 2x plus 3 plus 1. Multiplying out, we get lambda x squared subtract 2x plus 3 plus 1. Now that's g of f of x in general, but we're told that g of f of 2 is going to be equal to 16. That's like substituting 2 in here, so this would be lambda. If we put 2 in here, we would get 3 plus 1. So this is like solving 3 lambda plus 1 is 16. Subtract 1 of both sides, 3 lambda is 15. Divide both sides by 3, lambda is equal to 5. You may have actually, just thinking about it, I'm just going to rub that out just then. You may have found it, I'm going to make it smaller, slightly easier, first of all, to just work out f of 2. And if you would substitute, if you would put f of 2 into here, you'd have got that it was equal to 3. So therefore g of f of 2 is the same as g of 3, which is 3 lambda plus 1. And then you'd be solving 3 lambda plus 1 is equal to the thing they told you, 16, and you get the same as we did. Subtract 1, divide by 3, lambda is 5. Might have been slightly easier to do it like that. The next part, pause, take a look. This question is actually split over 2 pages, so I'll give you 5 seconds on each page. Next part. Okay, so I'll go through from the start. We are told this is f of x here, this is the function f of x, and the curve meets the axes at 0c and d0. On separate diagrams show the inverse function and this function 3f of 2x. I've drawn an extra axis here. The inverse function is the reflection of this in the line y is x. So I'm going to just draw a line y is x like so, and make it quite thin, just so it doesn't confuse us. Okay, maybe even dotted. Okay, so it's going to be a reflection. Apologies. So it's going to be a reflection in that line. Now the key thing about reflections are that at this point here is now going to get swapped over, and it's going to be over here at 0D. This point here is going to get swapped over, and it's going to be 0. It's going to be C0 even, C0. So we just reflect everything we see exactly as we see it. This here gets reflected down to this point here, and this point here gets reflected up here and continues on beyond the axis, just like this one. So they both look like a reflection in the line y is equal to x. Okay, and then this one, I'm just going to copy this graph one more time to draw this one. This is a set of transformations here. Firstly, we started off with y is f of x. Then what we did is we went to y is f of 2x. That's a compression by scale factor 2, a squash by 2. So 0, the x is 0 stays where it is, but this point here, where we cross, would now be d over 2, 0. The next thing we then did is multiply this function by 3. So this point here would be stretched up to 3c. So this would be over here at 0, 3c. Okay, 3 times higher. So it would come down like this, and it would cross half earlier, and it would go along like that. So the key points there, I'd say that this point here is 0, 3c. This point is d over 2, 0. Okay, part C, we're given that actually the function, we're told what the function is, and we're asked to find what C is. Now we are told that the function is f of x is 3 to the 2 to the minus x subtract 1. Now remember what C is. C is when x is 0, y is c. So you know 0c lies on this curve. So substitute x is 0 in. So f of 0 is 3, 2 to the minus 0, 2 to the 0 is 1. So this is equal to 2. So therefore c must be 2. So c is therefore equal to 2. What is the range of f? What are the values it can take? We'll look at the graph of f. The values that it takes are anything less than or equal to 2. So it's always less than or equal to 2. Now, just to state this here, f of x always has to be less than or equal to 2. But one key thing here, this looks like it's asymptoting. This graph looks like it's asymptoting. It's an e to the minus x graph. It is. It's asymptoting to the point -1, to the y value -1, because as x goes massive to infinity, this whole thing tends to -1. So therefore, f of x is certainly less than or equal to 2, but it's always bigger than -1, and it never quite reaches there. Okay, then find d given your answer to 3 decimal places. Let's go back and see what d is. D is when y is equal to 0. So we're going to solve f of x is equal to 0. F of x is 3, 2 to the negative x subtract 1. So f of x is 3, 2 to the negative x subtract 1 is 0. Add 1 to both sides. Divide both sides by 3. Take luns of both sides, natural logs, let's say. Bring down the negative x power. So negative x is ln a third divided by ln 2. Actually x, I could just say that x is therefore ln a third divided by negative ln 2. So if you type that in your calculator, ln a third divided by negative ln 2, you should get yourself the answer x is equal to 1.585 to 3 decimal places. That's part D done. For part E, it gives you another function. It tells you that g of x is log base 2 of x. X is a real number. X is bigger than or equal to 1. It asks you to work out f of g of x. So f of log base 2 of x. Now let's remind ourselves what f is. F is the following function: 2 to the negative x subtract 1. So I'm going to write that here to remind me. F of x is 2 to the negative x subtract 1. So I'm going to evaluate f at this point here, of this log base 2x. So it's going to be 2 to the negative log base 2 of x subtract 1. Okay, now we should know that negative 1 log b, for example, is like log b to the negative 1 to the power of negative 1. Just you can bring the power up. So this is like 2 to the log base 2 of x to the power of minus 1 subtract 1, and this is 3. Now 2 to the log 2x minus 1 is just x to the power of minus 1. So this is 3 over x subtract 1. And there, that is our f of g of x in its simplest form. And we're done. And the next question now is over 2 parts. So I'll give you 5 seconds on this page, 5 seconds on the next. Next page. Okay, let's work through this then. Here's our function. Show that its inverse is as follows. And write down the domain. Okay, we are told that f of x is ln 4 subtract 2x, and we're told that x has to be less than 2 as follows. So we could let y be equal to ln 4 subtract 2x. We could take exponentials of both sides, so e to the y, we're going to try and make x the subject of the formula, is therefore 4 subtract 2x. I'm going to add 2x to both sides and subtract e to the y, so 2x is 4 subtract e to the y, and therefore x is going to be this divided by 2, so it's going to be 2 subtract a half e to the y. So therefore f to the minus 1 is therefore x. It takes a value x and it works it out at 2 subtract a half e to the x. That's what you were after. And what's the domain of this inverse function? Well, it would be the same as the range of this. However, you can look at it more simply. Any x value can go into this with ease. So therefore the domain of this is x is simply just a member of the reals. Okay, part B, write down the range of the inverse function. What is the range of the inverse function? Well, the range of the inverse, range of f to the minus 1, must be equal to the domain of the original function. Now you know the domain of the original function is x less than 2, so therefore f to the minus 1x must be less than 2. And obviously f to the minus 1x must be a member of the reals, but reals less than 2. Part C, sketch the graph y is f to the minus 1x, state the values of its coordinates. So y in this case is going to be equal to 2 subtract a half e to the x. 2 subtract a half e to the x. And you are asked to draw this graph. Okay. First thing to note is that in general, an e to the x graph is going on here, an exponential graph. So an exponential graph looks like this in principle. Now if you multiplied it by negative a half, what would it look like? If you multiplied it by a negative half, it would reflect it in the x-axis and it would make it a bit shallower as well. So it would be something like that. And then if you added 2, to it, what would you be doing? Well, you'd be shifting it up by 1, 2. So this asymptote here would actually be at the y value, y is equal to 2. Now, what's the value here and what's the value here? Well, if x is equal to 0, y is 2, if x is equal to 0, y is actually 2, subtract a half, which is 3 over 2 or 1.5. So this point here is 0, 1.5. And if y is equal to 0, so if y was actually equal to 0, then we'd be solving 2 subtract a half e to the x is 0. So we could say that 2 is a half e to the x times by 2, 4 is equal to e to the x. So x must be ln 4. So this point here must be ln 4 and 0. And obviously, I should have probably just drawn here, this would have continued on like that. Then it tells us the graph of y equals x plus 2 crosses the graph y is the inverse of x at x is equal to k. And the iterative formula is used to approximate this route. Calculate x1, x2, give your answer to 4dp. Well, we were used to this in the iteration section. Type in your calculator negative 0.3 equals. That stores this in the answer function in your calculator. To work out x1, type in your calculator negative a half e to the ants, and it will tell you x1. By pressing equals repeatedly, it will tell you x2 and all the other ones that follow. So negative 0.3 equals, and then negative a half e to the power of ants, e to the of ants. For x1, I would get negative 0.3704, and for x2, I would get negative 0.3452. And I've got those two easy marks. Find the value of k to 3 decimal places. In order to do that, I just keep tapping equals on my calculator. So the next one, x3, would be negative 0.3540. x4, tap equals negative 0.3509. x5 would be negative 0.3520. x6 would be negative 0.3516, and x7 would be negative 0.3517. Now these have not repeated, these have repeated and they're the same. Therefore, because the fourth decimal place is higher than 5, both these to 3 decimal places would therefore be x is equal to negative 0.35, and you round up to 2. And that would be your approximate answer for k. Okay, next one. Pause the video, have a go. Okay, firstly we're asked to state the range of g. Now g is e to the x squared. What would a graph e to the x squared look like? Well, we know the graph e to the x looks something like this, don't we? But e to the x squared, well, imagine we put in, let's say, 1 in there. Say if we worked at g of 1, it would be e to the 1 squared, which is e. What would g of negative 1 be? Well, it would be e to the negative 1 squared, which would also be e. So the fact that we've got an x squared actually makes this an even function. So actually, it would be kind of like e to the x, but it would be actually an even function as so. And the range of it, this key point here, is y is equal to 1. The range of g of x, is therefore bigger than or equal to 1. Part B, show that the composite function fg is defined as follows. F of g of x, well, that's what we're asked to work out. F of x is 3x plus ln x, so f of x is 3 of x plus ln x. And g of x is e to the x squared, so g of x is e to the x squared. F of g of x is f of e to the x squared, so it's subbing in e to the x squared for x here, so it'd be 3e to the x squared plus ln e to the x squared. Well, ln e to the x squared is just x squared, so this is 3e to the x squared plus x squared, which is what we're asked for, x squared plus 3e to the x squared. Part C, the range of fg. We've got fg here. Fg of x is equal to x squared plus 3e to the x squared. Get the range of fg, here's our function y is x squared plus 3e to the x squared. What we're trying to do is find what values y can take. Now, we should note that x squared is always bigger than or equal to 0. And you should also note that e to the x squared, from the graph we drew on the previous page, that's always bigger than or equal to 1. So this here is always a positive number or equal to 0 at lowest. This here is always 1 or bigger. So this whole thing must be 3 or bigger. So therefore y must be bigger than or equal to 3, and that is our range. F of g of x is bigger than or equal to 3. Part D, we're asked to solve this equation here. If our function is y is f of g of x, and f of g of x is x squared plus 3e to the x squared plus 3e to the x squared, we are asked to differentiate it and make it equal to this. So dy by dx must be 2x plus, keep the 3 where it is, differentiate the x squared, we get 2x, keep e to the x squared as it is. So dy by dx must be equal to 2x plus 6x e to the x squared. Now that's dy by dx. We're asked to solve when dy by dx is equal to this. So we're going to solve 2x plus 6x e to the x squared is equal to this thing. I'm going to expand the brackets. I'm going to say that's x squared e to the x squared plus 2x. I can subtract 2x from both sides, and I can also subtract 6x e to the x squared from both sides. And what I can do here is I can factorise out an x and an e to the x squared. I would get x subtract 6 left here. Now, I know that e to the x squared is always bigger than 1, so that can't be contributing to the fact this is 0. So the only things that can be contributing to the fact that this is 0 is that the x here, that could be 0, or the x minus 6 could be 0, in which case x would equal 6. And that's our two answers for this question. Okay, and the last question now. Now this is quite a tricky question. It's going to just bear with me while I do this. There's a couple of things about this question. It firstly says it's an even function. And the question tells us it's defined between -4 and 4, -4 and 4. But the question only tells us what it's like between 0 and 2 and what it's like between 2 and 4. But we're supposed to know that the function is also like this between 0 and -2 because it's even, and the function is also like this between -2 and -4 because it's even. So let's try and draw this graph. I prefer using y's here. We know the graph is y is x, y equals x for 0 less than x less than 2, and the graph is y is 4 subtract x for 2 less than or equal to x less than or equal to 4. At 0, it goes through 0, 0. At 2, it doesn't quite get to 2, but it's the graph y is equal to x. It gets to the point 2, 2. So this point here would be 2, 2. And there would be a line, the graph y equals x, between those 2 points. I might even just draw it blue to make it absolutely clear what's going on. Okay? Then it's this graph between 2 and 4. Now, what does that graph look like? Well, all we need is 2 points to plot that graph. Let's put 2 in. 4 subtract 2 is 2, so we know it actually does fill that point. Let's put 4 in. 4 subtract 4 is 0. So I know it goes through 4, 0. I knew this went through 0, 0. So therefore, it must go down like this, and just to make it absolutely clear, I'm going to make that a red line. And there we go. We've drawn it between 0 and 4. But we know it's an even function, so we know it's the same between negative 4 and 0. It looks exactly the same, it's just a reflection in the y-axis. So it's a reflection in the y-axis. So we know, in particular, it goes through here. Let's call this point here. This point here would be negative 2, 2. And this point here would be negative 4, 0. So it looks like this, the other side of the axis as well, where that's supposed to be a perfect reflection. And that's the graph of f over its domain. Now, I am going to highlight all this because I'm going to need it to explain the next part of the question. Okay, part B, the tricky bit. We are asked to find all value of x for which the function we've drawn, f of x, is equal to this, x plus 4 over 4. Okay, so we are asked to find where f of x, I'm going to divide 4 into both sides, is equal to a quarter x plus 1. Where is this function, this complicated function here, equal to this function? Or where is it equal to the graph a quarter x plus 1? Well, let's draw the graph quarter x plus 1 here to see if we can work out where it is. If I wanted to draw this graph, I could let x be 0 and I'd get y as 1. So I know it goes through here. And if I let y be equal to 0, I would get x is equal to negative 4, just substituting in y 0. So I know it goes through this point here. So therefore this graph looks something like this. Now, therefore, this function meets this function at 4 points, here, 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 and here. And the question is asking us to find those 4 points. Well, by the graph and by a bit of work already, we've already found one of the points. One of the points is negative 4, 0. The question is now to find the other point. So one of the coordinates is negative 4, 0, which is that one. How do I find this one? Well, if this is, remember, this was the graph y is x, and this was the graph y is 4 subtract x. This graph here is a reflection of it in this line, so it must be the graph y is negative x. So to find this, it's where the graph y is negative x and the graph y is a quarter x plus 1, where they meet. So we can just make them equal each other. They're both equal to y. Negative x is a quarter x plus 1. Okay, add x to both sides and subtract 1. So negative 1 would be equal to 5 over 4x, and times by 4/5. X is therefore equal to negative 4/5. So this here is the values of here. So here's the other one, negative 4/5. It doesn't actually ask for coordinates, it just asks for x values. So one of our x values is negative 4, and this one is negative 4/5. How do we get this one? Well, we solve where y is x is equal to the graph y is a quarter x plus 4. Make them equal. X is equal to a quarter x plus a quarter x plus 1. Subtract a quarter x off both sides. 3/4 x is 1. So therefore x must be 4 over 3. So another one is 4 over 3. How do we find this one? Well, we solve where y is 4 subtract x is equal to y is a quarter x plus 1. Make them equal. 4 subtract x is a quarter x plus 1. Let's add x to both sides, subtract 1. 3 must be 5 over 4x. And therefore x must be, rearranging this, 12 over 5. Dividing by 5 over 4. So 12 over 5 is the other one. And they are the 4 solutions to this equation here. Quite a tricky question. And that's all now for the work on functions. So I hope you found this useful in your revision for functions. Thank you for watching.